Hello, students of class 12. My name is Shorav Pakrashi, and today I'm going to teach you a topic from the chapter Electrochemistry. The topic is Faraday's laws of electrolysis. In this topic, we will have three subtopics. That is, we will have a Faraday's first law of electrolysis, we will have Faraday's second law of electrolysis, and we are going to learn about the current efficiency. So let's start and we will get on to it. So at first, we will learn about the Faraday's first law of electrolysis. Faraday's first law. Okay. In this law, what does Faraday tells us? Faraday tells us that here the amount of weight deposited at any electrode. Suppose mainly the electrodes should be cathode where the metal ions will be deposited, because cathodes are negatively charged and they attract the positively charged ions towards it. So a cathode, the amount of substances that will be deposited at cathode will be directly proportional to the amount of electricity passed through it. That is W, if the W is the amount or weight of the metal deposited at cathode, then this is directly proportional to the amount of electricity passed through it. That is, W is directly proportional to Q. Okay. W is directly proportional to Q. And Q is what? Q is the charge. Q is the charge. C-H-A-R-G-E. Charge in terms of coulombs. Okay. Charge in terms of coulombs. Sorry, COU will be charge in terms of coulombs. Okay. So accordingly, we can say Q is equals to I into T. That means amount of current passed per unit time in seconds. Absolutely. Ampere seconds will give you coulombs. Okay. So this is I is current. I is current in amperes. Okay. In amperes. And T is time in seconds. Okay. So this is the charge which will deposit, means the amount of charge will be directly proportional to the amount of substance getting deposited at cathode. Okay. So this is the first law. So W is directly proportional to Q. W is directly proportional to Q, or you can see, if you change it, you will write W is directly proportional to I times T. And when you remove this proportionality sign, there will be a constant. In this case, the constant will be an electrochemical equivalent, or Z. Okay, so W equals to ZIT. This Z is known as electrochemical equivalent. Z is known as electrochemical equivalent. Okay, Z will be known as electrochemical equivalent. So what is electrochemical equivalent? So equivalent means the equivalent weight that we have discussed. And electrochemical equivalent means it will be divided by the amount of current, okay, amount of charge that is produced by one electron. Okay, amount of charge produced by one electron. Now, sorry, 1 mole of an electron, not one electron, 1 mole of an electron. So 1 mole of an electron, 1 mole of an electron is equals to 6.023 times 10 to the power 23 electrons. Okay, one mole of an electron is equals to 6.023 times 10 to the power 23 electrons. Now, charge carried by 1 mole of an electron. Charge, I will write it from here so that you can see. Charge carried by this 1 mole of an electron. charge carried by this 1 mole of an electron is 6.023 times 10 to the power 23. Nowadays, it is written as 6.022, but you can write it 6.023. Actually, 6.022 is only up to class 10. Now you can write it as 6.023 as well in this part. Okay, times the charge of an electron. Charge of an electron. Okay, so what is the charge of an electron? The charge of an electron is 1.602 times 10 to the power minus 19. Charge of an electron is 1.602 times 10 to the power minus 19 coulombs. Okay, so you can see, so you can see that 10 to the power minus 20, 10 to the 23 and minus 19 will give you 10 to the power minus 10 to the power 4, and here it will be something like 9.650, okay, like this. So it will be approximately 96500 coulombs. Okay, 96500 coulombs. So 1 Faraday, or the amount of charge carried by 1 mole of an electron, amount of charge carried by 1 mole of an electron is equals to 1 Faraday. Okay, so now you will write it as the electrochemical equivalent, or Z, electrochemical equivalent, or Z will be equal to equivalent weight. Z will be equal to the equivalent weight of the metal ion, equivalent weight of the metal ion, equivalent weight of the metal ion divided by 96500 coulombs. So this will be your electrochemical equivalent. Therefore, we can write W equals to ZIT, or we can write it as E by 96500 times I into T. Okay, this is how we can write. This is the Faraday's first law of electrolysis. This is the Faraday's first law of electrolysis. Now let us come to the second law. Let us come to the second law. What is Faraday's second law of electrolysis? Faraday's second law of electrolysis. Faraday's second law. So in Faraday's second law, what we will see? In Faraday's second law, what we will see that if we connect, suppose we are connecting several cells, okay, several electrolytic cells together, okay. Suppose we are connecting several electrochemical cells together, okay, and they are all connected with the same source, okay, means the amount of charge passing through these cells are same, okay, the amount of charge passing through these cells are same, okay. If the amount of charge is same, that is Q or IT is same here, Q or IT is same here. If we are saying that if we are passing same amount of electricity, so it will be the same amount of current passing through all the 3 chambers where electrolysis is being conducted. So if this is same, this is constant, so what you are left with? You are left with the weight deposited equals to equivalent weight by 96500. So you can write here that if IT is also constant, so you can write that W by E, these two are only variables, and all this IT by 96500, this whole term is becoming constant, okay. So as this whole term, and W and E, these two are only variable and the ratio is constant. So you can say that in all these cases, if here the W1 is deposited, here W2 is deposited, and here W3 is deposited, means weight of the ions which are being deposited here, you can easily say that W1 by E1, W1 by E1 will be equal to W2 by E2, and this will be equal to W3 by E3, like this. So as they all are same, because their total, as I is constant, the time is constant, and 96500 is always constant. So this W by E means the weight deposited by its equivalent weight deposit of the metal by the equivalent weight of the metal. This ratio will always be constant if we are putting the same thing in a series. Okay, so this is the Faraday's second law of electrolysis. This is the Faraday's second law of electrolysis. Okay, now let us come to the third segment of this topic, which is subtopic. Sorry, the topic is third segment, the third subtopic of this topic. The third subtopic of the third segment is current efficiency. Okay, so the third one will be current efficiency. Current efficiency. Okay, what is this term current efficiency actually means? The term current efficiency means suppose you are doing some work. Okay, suppose you are spending some time for doing some work. Now after some time you feel bored and you started watching any reels or any YouTube video or any other things. Okay, so that is distracting you. That means the efficient amount of work is reducing. Okay, the amount of time that has been given to you, is now being reduced. Understood? Because you are facing some distractions. Here also, whenever we are talking about current efficiency, the same thing has happened. Suppose you are passing some amount of current for certain period of time, but actually that whole amount of current are not being getting used. Suppose you are passing 100% current, 10 ampere of current, and only 5 ampere work of amount 5 ampere is being done. So that is known as shortage, or it is not showing their 100% efficacy. So current efficiency, we can write in this manner. Current efficiency is the actual current required, divided by the current supplied, okay, times 100. This is your current efficiency. Actual current required by current supply times 100. It is similar to that of a percentage composition. Okay, it is similar to that. Means the formula is similar to that of a percentage composition. You can also say the percentage of electricity being used. Okay, the percentage of electricity being used. So this is how we can actually do the questions of any examination like JEE, NEET, and other things. So let us go and find out, is there is some what type of questions will you face in your competitive examination. Okay, so let us come here. Yeah, so this is an interesting question. It states that potassium chlorate is prepared by electrolysis of KCl in basic solution. This is the equation that they have given you, and they have stated if only 60% of current is utilized in this reaction, the time required to produce 10 gram of KClO3 using 2 ampere current is how much? Understood? What they are trying to ask is that potassium chlorate is prepared by electrolysis of KCl in basic solution. And they have given you this. That means this ClO3 minus is actually KClO3 minus. You are using KCl here. So it will be KClO3 minus and 6 electrons. So in the equation, whenever you are solving any questions like this, where this amount of current is given and they are asking you how much amount, how much time you will get. So this type of questions always have these electrons in them, number of electrons. Okay. Or they will give you a charge and they will say the metals will get deposited. like they sometimes will give you that, they will sometimes give you like this, that Al3 plus to Al. That means you have to understand that it requires 3 electrons to produce this aluminium. Okay, so 3 electrons means 3 Faradays, because we are using 1 mole for 1 mole of Al3 plus, 3 moles of electron are required. So 1 mole of electrons is 1 Faraday, 3 moles of electrons will be 3 Faraday. Okay, Faradays are represented with F, means 3 into 96500 coulombs. Okay, 3 into 96500 coulombs. Similarly, when we are doing this question, they have given you this equation. What was the equation? Let us check once more. They have given you 6 OH minus plus Cl minus, ClO3 minus, 3 H2O and 6 electrons. So they have given you, again it has gone, they have given you the equation 6 OH minus plus Cl minus, from here you are getting ClO3 minus plus 3H2O and 6 electrons. Now in this equation, as they have already given you 6 electrons, so you will write here 6 Faraday of electricity. Means 6 Faraday of charge is the amount of charge that will be required to produce 1 mole of this ClO3 minus or KClO3 minus. Okay. Now they have given you the molar mass of KClO3 is 122 gram per mole, means the molecular weight of KClO3 is 122. Molecular weight of KClO3 is 122. And Faraday is also, they have given you 96500 coulombs. Yes, 1 Faraday is 96500 coulomb per mole. Okay, so they have given you these two things already. Now, they have also stated one extra thing in the question, that the current efficacy or efficiency, only 60% of current is utilized in this reaction. Okay, means the amount of current, this is the current efficiency. 60% of current is utilized, means current efficiency. So we will go from the third segment, that is current efficiency is equals to the amount of current, means the actual current required. Okay, the actual current required that we do not know. Let us take that as X. Okay, let us take that as X, and they have already given you that, sorry, actual current required is 6 Faradays, means 6 into 96500 coulombs, and the amount of current that they have supplied, they haven't given you total amount of current, they haven't given you how much. So you will just write here X, and it will be times it 100. So current efficiency they have given you as 60%. Okay, and here it is 6F by X into 100. So you cannot write F also here, times 100. So therefore from here you can write X equals to 10 Faraday. Okay, X equals to 10 or 10 Faraday. Understood? Like that. So if you do 6 Faradays, then you will get as X equals to 10 Faradays. Like this. So total amount of current that will be required, as current efficiency is given as 60%. So total amount of current that will be required will be 10 Faradays. Total amount of current that will be required will be 10 Faradays. Now, so here the statement changes. From the equation, we saw that 6 Faradays of electricity was required. 6 Faradays of charge was required. But now we will write as current efficiency is 60%, as current efficiency is 60%, so 10 Faraday of charge is required to actually deposit 1 mole of KClO3. Understood? So this is how we will move on with our question. This is how we will go to the next step with this statement in our mind. Now, next what we will do? Next, we will just understand what is there. Okay, next we will understand that 1 mole, what does 1 mole means? So 1 mole of KClO3 requires 10 Faraday of electricity or charge, you can say, on that segment, on that fashion. So 1 mole means 122 grams of KClO3 requires 10 Faraday of electricity or charge, whatever. So according to the question, they've asked you about 10 grams. So 10 grams of KClO3 requires how much? 10 by 122 times Faraday of electricity or charge. That means 100 over 122 Faraday. Okay, 100 over 122 Faraday. So this is how much the current is required. This is how much the current is required. Understood? This is the overall current that is required. Now, let us go to the next part, what it asked you about. They have asked you that if 60% of current is utilized in this reaction, the time required to produce 10 gram of KClO3 using 2 ampere. So now they have asked you if 60% of current is utilized. 60% of current is utilized. So you have to find that time using the current of 2 ampere. So your first segment here, it is already, we have found out that this is the amount of current that will be required to produce 10 gram of KClO3. This is, so here we are going to apply Ampere's Coulomb law. So we are going to apply Ampere's Coulomb's law, okay, to complete our question. We are going to apply Ampere's Coulomb's law to complete our questions. This is Q equals to IT. Okay, Q is already given here as, we have already found it out as 100 over 122 Faradays equals to, the current is 2 amperes and time is what we have to find out. Now, we'll write here what is Faraday, 96500 coulombs. Okay, so it will be 100 over 122 times 96500 divided by 2. This will be your time. Now this time will be in seconds. Okay, this whole time will be in seconds. Okay, because here it is ampere and this is coulombs means ampere seconds. So whole time will be in seconds. Now you have to do some of the maths here. That is, you have to cancel this 100 by 2. You will get 50. You cancel this. You will get 61 from here. And from here you will get how much? Okay, you can cut this also to get 25. Now you can, will be T equals to 25 times 96500 over 61. The 61, you can take it as approximately 60. You can take this as approximately 60. Okay, just for the calculation, for the sake of calculation, you can change it to approximately 60. So it will be 9650 by 6. Okay, 9650 by 6 it will be. Now you can divide this with 2, you will get 3, and if we do this, you will get 4825. So here what you are having is T equals to 25 times 4825 divided by 3. Okay, 25 times 4825 divided by 3. Now, as like we have considered 61 as 60, we can consider this 25 as 24 approximately. Okay, we have reduced 1 from here and we are reducing 1 from here as well. Okay, so approximately 4825 divided by 3, and you will get here 8. 8 times 4825, and remember we have already discussed all are in seconds. Okay, all are in seconds, so it will be 8 times 4825, and the question they have asked us that we have to find this in hours. Okay, in the questions they have already asked you to find it in hours, round to the nearest hour. Okay, so as we are rounding up to the nearest hour, okay, as we are rounding up to the nearest hour, we will divide it with 60 times 60. It's for 1 for minute and 1 for hour. Okay, now this is, you can write it at 8 times 4825 by 6 times 6 times 100. So why I'm converting this to 100? Because this 4825, here you cannot divide it with 5. You can divide it with 5, but it will be a hectic one. So apart from that, if I do it like 8 times 48.25 by 6 times 6, and here 25, if I convert it to 48.3, then the equation is for solving, it becomes easier. Okay, 48.3. Now we have all, we can divide this with how much? 4. This will be 3 again. 2 2s are, this will be 3. Now 48.3 divided by 3, if you do it, you will get how much? 12.1. Sorry, I don't think it will be 12.1. It will be 3 1s are 3, and then it will come as 8. So 3 means 18. 3 6 are 18. 16.1. Okay, I think it will be nearly 16.1, and 16.1 divided by 2. 16.1 divided by, sorry, 3. How much will it be? You can take it as 16.2 as well. 2 times 16.2 divided by 3. So 5s are 15. 1.2 means 5.4. So it will be approximately 10.8 hours. Okay, so this is how you can easily do the questions. Whenever you will be stuck in some questions, you can do those easily. Okay, so this is one of the questions that you can do. We can do some other questions as well from here, like let us do question number 19. Here they have asked you that 250 ml of waste solution obtained from workshop of Goldsmith contains 0.1 molar AgNO3 and 0.1 molar AuCl. Okay, the solution was electrolyzed at 2 volt by passing a current of 1 ampere for 15 minutes. Now this voltage is unnecessary, okay, because in Faraday's laws of electrolysis or from anywhere, voltage, how many volts of currents you are using, you can, because ampere and time is given, from here you can calculate the time required. Volt is not required in this segment. So yeah, the current means the voltage has been given and it's good, but it is not of a very much use. Okay, where voltage would be used is that when we will be solving about electrochemical equations like E0 cells, Okay, how will they come and go? For those questions, these voltage values will be important, not for this type of questions, because they have given you here the metal or metals electrodeposited will be. Now, for these type of questions, we can easily do the things that it is 250 ml of waste solution. So how much amount of AgNO3 is there? How much amount of AuCl is there? For this type of questions, see, the question has not asked about to do all these things, but rather we can do it. Okay, 0.1 molar 250 ml. This means how much moles? This implies moles is equals to volume times molarity. Okay, it implies volume times molarity and volume in liters. Okay, it will be 250 by 1000 times 0.1. Okay, so this is your number of moles. So it will be nothing but 25 times 10 to the power minus 3. And as 250 ml is 250 ml contains both 0.1 molar AgNO3 and 0.1 molar AuCl. So in both cases, this will be your number of moles for both. Okay, but this for this equation, this information is also null and void. It does not require to do all these things. Okay, but I'm still going to show you one thing that here also you can do it, that here AgNO3 from AgNO3 you will be getting Ag plus and you will get one electron and this much will be deposited. So 1 mole of an electron will be used. Similarly, from AuCl also Au plus will take 1 electron to deposit 1 mole of a gold. Okay, and this 1 electron means 1 Faraday for each. Okay, for and the electrons are same. The number of current, the passage of time, both are same. Okay, so weight deposited by equivalent weight, from there also you can calculate it, but it is also not required to do all those things in this part. Okay, because number of moles, from number of moles you can easily calculate that how much number of moles of both of them are equal. Okay, so as number of moles of both of them are equal, current passing through the solution is also the same. IT is also the same. Here they have given you that 1 ampere for 15 minutes means it has been, all the things are same for these two. Now the metals that in the metal or metals electrodepository will be, you have to find these things. Here it is electrolyzed at 2 voltage, but Ag has a standard reduction potential. Why it is reduction? Because Ag plus to Ag means reduction is happening. So this is a standard reduction potential value. So higher the standard reduction potential value, higher the standard reduction potential value, the more probability of that element will be for deposition. Okay, if as gold here has a higher standard reduction potential value, so here gold will be deposited first, then this what is called silver, this will get deposited. At first gold will be deposited and then silver will get deposited. Okay, so here the answer will be only gold. Let us come to the third question. Here you can see an acidic solution of dichromate. Here also the same thing, that efficiency in the process. So you have to find the same thing, that 6 electrons means 6 Faraday, and from here you can do it. And right now I can say that this type of questions are very common, and this type of questions will come in your JEE and JEE Advanced. And the other questions are here, they are also very similar to them, and they're very easy to do. You have to just follow the formulas and just understand what the question asks from you. Okay, and accordingly you can. So I'm taking a leave now. Okay, bye bye.